Okay, so let's get started. Hello and welcome everyone. Thank you for joining us in this session. It's a polyglot world, enabling every developer to build distributed applications. My name is Singh Chauhan. I work as Cloud Solution Architect in Microsoft, and I'm co-presenting this session with my colleague Mark Fussell, who works as Principal PM Manager in Azure Incubations team. So in today's session, first we'll talk about cloud native applications. Like, what are cloud native applications? Why we should use cloud native application, or why should we build our application in the cloud native way? Then we'll talk about some challenges associated with building cloud native applications. We'll talk about different elements of cloud native like microservices, DevOps, and other things. Then we'll talk about the distributed application runtime, Dapr. We'll talk about that. What is Dapr? Why should we use Dapr? Why should you use Dapr for building your microservices application? Then we'll talk about the sidecar architecture of Dapr. And then we'll talk about building blocks of Dapr. And we'll show you some components each building blocks have. I will also show you a lot of demos. And then in the end, last 10 to 15 minutes, we'll take Q&A session. Do let me know if I go very fast or very slow, or if there is something which you don't understand. There is this Slack channel where you can post your questions. So let's first talk about what is cloud native. You might have heard this cloud native so much in last few years, like cloud native applications, cloud native architectures, or platforms or processes. So what is this cloud native? So with this slide, I'm trying to have a common understanding, because this understanding is what we are going to use going forward. So cloud native is an approach for building application and services specifically for cloud environments like public cloud, private cloud, or hybrid cloud. It's an adjective which describes application, architectures, platforms, processes, which together makes possible for us to quickly respond to changing user needs and business requirements. In simple terms, as shown in this slide, cloud native is application code and dependencies packaged as containers, deployed as microservices, and exposed as APIs. And this pretty much you can manage with DevOps tools and processes. Now I have defined what is cloud native, but why should I care about cloud native? Why should I build my applications in the cloud native way? So there are three main advantage I get out of building my application in the cloud native way. First, I get the speed of innovation. By use of techniques like DevOps or containers, I can quickly take an idea, build an application, deploy it to production, give it to my users, and with a transparent feedback loop, I can see how my applications are doing. I can learn something from it and change my further course. As I explained, that cloud native heavily relies on cloud. So it makes most of the benefits provided by the cloud, like scalability, resiliency, availability, and so on. So when you build this cloud native application, you get a lot of reliability, which is provided by the underlying platform. And by making use of platform services like databases or identity store, you get more guarantee that your application will be always up and running. Because cloud is secure at its core, you automatically get these benefits in your applications. And cloud native is the new way for building applications, specifically when public, private, and hybrid cloud are at rise. Now I've spoken about what is cloud native, why should we use it. Let me show you some scenarios where cloud native application architecture can be useful. First is you can utilize it when you want to modernize your business critical applications. You can use it when you want to build SaaS solutions. You can use building real-time telemetry solutions where you want to ingest data from devices on the field. One very good scenario is the edge devices or edge computing. And then the last, you can use cloud native approach to build geo-distributed applications. Now, I have spoken about cloud native's benefits and some scenarios. Let's talk about one of the very important pillar of cloud native, which is the microservices application or architectures. So what is this microservices? You might have heard a lot about microservices in last few years, but there is a reason why it is so popular now. So let's try to explain what is microservices. Microservices is a software architecture style where you build a system in form of small independent services which are very much decoupled from each other, meaning that if you change one of the service, and as long as you keep the interfaces by which these services talk to each other consistent, other services are not going to be affected. Even if you introduce new changes in interfaces, it's going to be controlled, then you are good to deploy your application. One of the big advantage of these microservices application is that all these services can be independently versioned, can be independently deployed and scaled. So if you see this monolith diagram over here, an app which consists of modules or services over here, when it has to scale, it scales as a single unit like this. It will go same. But in case of a microservices application, which is now composed of sorry, which is now composed of different services, when it has to scale, different part of the application, which are services, can scale. So for example, if I'm building an e-commerce application and suddenly I have a lot of orders, my order service can scale up or down depending upon the load. I'm talking about microservices, but there is a reason also comes from so much market research that why we should care about microservices application. As you can see that from IDC, they say that 90% of new apps will feature microservices architecture by 2022. They also say that 35% of all the production apps are cloud native as compare will be cloud native by 2020 as compared to less than 10% as of today. Second thing is that if you hear about any new startup or any new project, they might be considering this microservices architecture. So that's why building your application in microservices way so that your application become cloud native is a very good approach. Now let me show you one example of a microservices application. So when I started my career, I was part of building some web applications. And at that time, I built all those applications as layered architecture, or actually now we call them monolith. And I still remember that everybody, whenever I go for a new job interview, they were asking me about this layered architecture and its benefit. But that was very valid at that time. I have developed those e-commerce application pretty much layered, the presentation layer, the business layer, and the database layer. But there was a problem with it. When I have to do changes or if I have to do new deployment, I have to deploy pretty much everything again and again. And when I have to scale, I have to scale as a single unit. Of course, I could have done like distributed monolith, but still it was very difficult to do. And combined with processes like DevOps, which never used to be exist at that time, things can become quite difficult for me. And that's why microservices application is the way you build your application wherever it is possible. So as you can see in this example e-commerce application, we have divided the system in different services, like this front end service, which is handling all the requests from internet. Then it has a stateful cart service, which is speaking to this stateless payment service and the shipping service. And it is storing its state in the Cosmos DB and listening to some Kafka messages. So this is the new way of building applications, the microservices way. One of the beauty of this approach, as you can see that this is a high level representation of a system, I can implement each service with a different technology stack. I can use React for front-end service. I can use ASP.NET Core for payment. I can choose any language or programming model or framework wherever it makes sense. So that's what I get out of microservices. Now we spoke about microservices, we spoke about cloud native, but it's not that easy. All these new things, they bring a lot of challenges for us as developers. So the first challenge is that we are always asked to build this resilient, scalable microservices-based application, which is not that easy. We need to utilize multiple languages and frameworks during developing these applications. Last, we as developer, we want to focus on our application. We want to focus on building the application on the business logic and our development instead of focusing on infrastructure. So we spoke about microservices. Microservices can really help us, but it's not that easy. There are some challenges in building microservices application. So I have listed down top 3 challenges with this approach. So the first one is that it's very hard to incrementally migrate from existing source code to the microservices architecture. Meaning, if I'm one of the pattern you will find out there is that people are converting their existing layered architecture or monoliths to microservices, and that transition is not that easy. You need to really be master in this transition patterns. I, as a developer, would like to utilize as much as my existing code and wrap it inside a service. Second thing is that there are programming models and frameworks which have very narrow language support, plus they have limited set of features. So for example, if I'm targeting an environment or if I'm using a programming model or a framework which does not give me, say, a feature like event driven or state management, then I'm very much limited what I can do with my service or my application. The third thing is that these runtimes or programming models, they pretty much target a specific infrastructure. And one of the thing because of this thing happens is that I have very limited code portability. I cannot take my code and run it in cloud and in edge devices or anywhere else. So now we have spoken about all these challenges. Now I'll jump into the next part of the presentation where I'll show you the solution for all these problems, a possible solution which you can consider to build your application. So for the most part of this session, I would like to focus more on the distributed application runtime, also known as Dapr. So let's start talking about Dapr. Dapr is a portable event-driven runtime that makes easy for us developers to build microservices application and in a way, distributed application. And I can take this application and run it on any cloud, say Azure or AWS or Google, and I can also take it to edge devices also. Now, before I go and tell you about like how Dapr is built or what are the components and features it provides to you, I would like to tell you some goals, the principles Dapr follows. All these microservices application, they have some common set of challenges like state management, secret management, pub sub, and others. And what Dapr does for you is that it takes all these common scenarios, take the best practices and codifies it. So when we will talk about the building blocks of Dapr, like state management, pub sub, other things, these all building blocks are actually built based on the best practices of the respective area. Dapr works with any language or any framework. That's the beauty of Dapr. Because it exposes the functionality over standard protocols like HTTP and gRPC, you can use it in any language or any framework. The Dapr team, together with community, has created so many SDKs for you to get started. But if you are using a language where the SDK is not available, you can still the standard way for calling Dapr functionality. Dapr is a project started by Azure Incubations team in last October with collaboration with the community. So it's not very old project, it's fairly young. And as of this Tuesday, it's in release 0.8.0. And if you can see that most of the functionality which is there in Dapr comes from community. So I think it has, as of today, is like 150 contributors, and it's very much vendor neutral. It's not owned by one company, it's purely community driven. Wherever possible, we have adopted standards for building Dapr. So like open telemetry or cloud events, we have followed these standards so that you get an application which is quite portable. Dapr provides consistent, portable, and open APIs. They work same across cloud and edge. It's platform agnostic. It does not target any specific environment or any specific orchestrator. And last, but the most important part of Dapr is that it is pretty much extensible and it has a pluggable component model. So when I will show you different blocks of Dapr, I'll show you that each block is backed up by one or more components which you can swap. So this is a high level picture of Dapr. As you can see in the bottom of the slide, these are the clouds or edge infrastructure where Dapr can run. It can run pretty much on all the public clouds. It can run on your on-prem. It can run on any orchestrator like Service Fabric or Kubernetes or on the edge. The middle part shows the features of Dapr, including its building block like service-to-service invocation, state management, publish and subscribe scenario, bindings, the virtual actor model. It provides you distributed tracing with the observability block, and then it gives you a opportunity for secret management also. And as you can see that pretty much all this functionality is exposed in form of HTTP or gRPC API. That's why you can use Dapr functionality in any language or any framework. One of the thing is that if I'm using Dapr in my application or in my service, I can choose which blocks I would like to use. So I can choose to use just service to service invocation and state management. So in one of the demo later today, when I will show first demo, I'll be only using the service to service invocation and state management. And you can mix and match these functionality. And that's why Dapr plays very nice with other things like service meshes or any other software out there. Now, before I jump into talking more about the building blocks, I would like to show a conceptual diagram that how a building block operates. So each building blocks is exposed as HTTP or gRPC API, and it is backed up by one or more components. So for example, when I'll show you in the next slide is that one of the block is like state management, and the component which is providing functionality for that block can be Redis, it can be Azure Cosmos DB, it can be SQL or DynamoDB. With just few lines of change of the code in configuration, I can swap the component. Now, how you use this Dapr building blocks in your services? So Dapr runs as a sidecar process or a container, and it is exposed to your code as a local endpoint. So as you can see here, Dapr runs as a sidecar, and pretty much you can get all the functionality out of Dapr with this local host call. So as you can see here, I'm doing a local host call on port 3500 where my Dapr sidecar is running, and I'm doing some operation like state or service to service invocation. Dapr runs in two mode. One is the self-hosted mode, and another is the Kubernetes mode. In self-hosted mode, this is your application code, which is talking to its Dapr sidecar, and this Dapr sidecar is running as the process. And you can see that it is exposing the functionality of these building blocks by standard HTTP or gRPC API. The same service, when executed in an orchestrator like Kubernetes, it runs as a sidecar container. So you can see that in this pod, my application code is running in the container, and the Dapr sidecar is running as another container in the same pod. Now, let's talk about what happens when I run Dapr as a sidecar in the self-hosted mode. So this slide shows that I have two services, service A and service B. This is the sidecar for service A, and I'm accessing all the functionality provided by Dapr by making calls to my local endpoint and save for this service. Now you can see that this service is making use of the state management building block, where you can use any state store, say Redis, Cassandra, DynamoDB, or Cosmos DB. I can use any publish or subscript store like NetServe or RabbitMQ, Service Bus, or Redis. In the same way, I can also subscribe to events, input bindings, and output bindings. I can subscribe to event hubs, Kafka messages, AWS SQS, or GCP PubSub, and many more. So all, as you can see, that this is the building block, and these are the backing components. Most of these components come from community contribution. A very important thing to see here in this slide is that if this service needs to talk to this service, I don't need to follow this path. I can pretty much make the call to my Dapr sidecar, and then this Dapr sidecar will speak to this Dapr sidecar on behalf of my service. Now, when you run Dapr in the Kubernetes mode, it utilizes the Kubernetes operator model. And you can see that this is the operator, Dapr operator running in Kubernetes, like operator, sentry, sidecar injector, and actor placement. And whenever I do deployment, just by putting some annotations in my deployment, I can make this service Dapr enabled. And then these components running in these services running in Kubernetes environment can pretty much use of any component. This can run in AKS, this can run on AWS, this can run on GCP. Now let's talk about few building blocks. So the first and the most simple one is the state management. Any microservices application, whether it would like to make use of state management in form of key value pair. So as I show you in this slide, I have one application called my app, which is posting data to the state store, and it's doing it by Dapr. So here I'm posting data to my state store. As you can see that this part of the URL, I'm making a sidecar call to my Dapr sidecar, and I'm telling that I would like to utilize the state block, and I will give the name of a store, and I will pass on the data. What Dapr will do on my behalf is that it will check in the configuration that what is the chosen state store. Let's suppose in case this is Redis, it will take that store and store my data to it. Next time, when I will retrieve the data, I will just issue a HTTP GET command, and I'll say that, see this pattern, that I would like to again utilize state, and this is the state store name, and this is the key I would like to get. And then Dapr will return you the data. The next scenario I would like to speak, or the building block, is service to service invocation. So in this scenario, there is a front-end application and there is a cart application. The front-end application want to do checkout, and look at this URL. It is invoking a method called checkout on my cart service. Look at this one. I'm posting a message to my Dapr sidecar and I'm telling that, hey, I would like to execute this checkout method on my cart service. And this is the data. This is the parameter for the checkout. This this call will flow from this Dapr sidecar, will go to this Dapr sidecar, and ultimately to the service, and it will perform the action. So I have done enough talk. Now I would like to jump to a demo where I would like to show you that how these things are done in practical way. So I'm showing you an example over here. This is my this is a source code I'm using from the Dapr samples repository, which we have used in our Dapr workshop yesterday. You can freely get it from GitHub. Now, if I would just like to show you two parts of this application. So I have two services over here. One is the node application, which is accepting the order, and one is the Python application, which is posting the order to this node service. Now I will be demonstrating two scenarios in this demo. One is the service to service invocation and state management. So let me show you. I'll go here. And I will start my node application which accepts the order. As you can see that I'm running my application with Dapr. So when I execute, look at this command, Dapr run. The app ID is node app. The port for the application is 300 and the port for the sidecar is 3500. And this is the command to run node.app.js. So it's starting, as I can show you here, it's starting a web server. So this is the code. Express application, and look at this part of the code. When the Dapr runs, it injects the Dapr HTTP port. If there is nothing, it will try to default it to 3500. Now I'm choosing a state store, and then I'm preparing a URL where I can make my request. And then I'm creating three endpoints: HTTP get for order, for HTTP post for posting a new order, and for deleting the order. So now my application is running. As you can see, it's now ready together with Dapr sidecar. And let me show you something. So if you do Dapr list, it will show me the application or the sidecars which are running. So as you can see that now my node app is running. Now I'll try to post some orders to this application. So I'll go here. I'll open this sample HTTP file. And I'll go on the console over here so that you can see the messages. I'm using, by the way, I'm using a Visual Studio plugin called REST Client. And now I'm going to make a post request. As you can see that I successfully posted an order to my node application, and it stored it in the Redis cache. I have configured Redis as the state store for my node application. Now, one thing I would like to show you is that look at here. This is my Redis local Redis cache, and I'll look at the order. And I have the order over here. So I posted order ID 43, and it's now stored over here. Now what I will do is that, because this is an example of that I'm directly pasting a order to my node application, I'm going to start the next part of this thing, this application, the Python application. Again, going to open this. And I'm going to start my Python app. And before I start my Python app, I just like to show you the code for Python app. This is a very simple Flask application where it just prepare a message like data, order ID, and start posting it to the Dapr URL. So as you can see over here, same thing what was happening in the node application. It is getting the Dapr HTTP port environment, or actually is trying to find out where the sidecar is running. And then once once it has access to its sidecar, is invoking the method on node app, the new order one. I shown you a few minutes back. So let's start this application. So the Python app is up and running, and the sidecar is listing on 5510. I can go here and I can check Dapr list. And I have two applications, the node application and the Python application. Now look at the node application, which is receiving the order. As you can see that it is receiving the order 5, 6, 7, 8, because I'm making this thread to sleep for a few seconds. So it's receiving the order. And let me go and see my Redis cache. And I have order 11. And I have order 12. So as you can see, that so simple. I'm using Dapr's functionality for state management and service to service invocation, and keep moving that heavy lifting out of my code. I would just stop this. Wait. Let me start it once again, because I would like to show you something. Okay, it's running. If you go over here and just do get process Dapr, you can see that I have two Dapr process CLIs running, and then I have two Dapr sidecars. These two sidecars are for my node and the Python app. Now I will stop this application and I'll switch back to my demo, or actually to my slide deck. Now I have covered service to service invocation and state management. Let's talk about the next building block. The next building block is observability. So when you build this microservices application, where your application is built of these so many services, let's take the example of this e-commerce application. Now, if you have to do distributed tracing of the calls, like somebody posting an order and checking it out, what is happening? It's very difficult in a microservice application if you try to implement it by yourself. What Dapr does, if you remember, I told you that one of the building block is observability block, and it follows open telemetry, or actually open census, which is now part of open telemetry. And by using this, you can do distributed tracing and export the metrics and logs and data to any of open source software like Prometheus or Zipkin or Jaeger or Application Insight, anything which follows open telemetry. So I just would like to go back to my demo, the same demo, and just would like to do some changes here. So I'll go here, and this time I'm going to pass on a new parameter to my node application, and this is this config parameter, and I'm saying that turn on tracing by this tracing YAML file. I'm saying that please turn on tracing, and this is the sampling rate. I will turn it on. And I will do the same thing for my Python app. So I'll just hit the top arrow button, and I will just add a new parameter called config components. Tracing.yaml. The moment this Python app starts, it will start posting again messages to or orders to my node application. Yes, I'm getting it. Now let me show you something. I have already configured Zipkin. So for this demo, I'm using Zipkin. So I have Zipkin installed. You can check more about Zipkin on internet. But Zipkin is a software where you can collect and analyze your logs. So as you can see that here, because I have turned on tracing, I'll see those logs. And as you can see that, I can see these logs, and I can also see the dependency one. Let me just change it for a minute. And it is showing how my Python application has spoken to my node application. And this will go on. So it's showing me the traces of everything happening between my two applications, all just by turning on tracing, just by a YAML configuration file. Now, as a more complex scenario, what I have done in the morning that I created a distributed calculator where the calculator has add service, subtract service, multiplication service, and a front-end React calculator. And I have turned on tracing on them, and I'll go and I'll show you that how it looks like. So you can see that my front-end application, just disregard this one, sorry. Let me change this time frame just to be. So I built a distributed calculator over here. And you can see that this front-end calculator is making calls to add app, multiply app, divide app, and subtract app. And it's showing me all the information, how the calls are happening between these services. I'll go back and I will stop my Python. Now let's talk about other building blocks. The publish and subscribe building blocks. So one of the scenarios is this microservice application is pub and sub, where there is a publisher and a number of a subscriber. So as you can see that for publish and subscribe scenario, I'm again using Dapr. So when my application runs, I'm publishing the orders, and then there are multiple subscribes over here which have subscribed to my service. And as you can see that once I publish an order, it goes to my shipping or email service. If you remember the example I have shown you before. And as you can see that the component which is actually backing up this pub sub scenario is Redis, but you can pretty much change it with anything else like NetServe or Service Bus or anything else. With just change of few configuration parameters, you can quickly change the underlying component for a building block. I hope I make sense. Now let's talk about the next building block, which is bindings. Bindings are very important because you want to build a system which is event driven. Meaning is that I would like to react when something happens outside of my system, or I would like somebody else or some other service or code to react when something is happening in my service. So this is the building block. The bindings provides you two kind of bindings, input and output. And actually yesterday they also released bi-directional binding. So you have input bindings where your code get executed based on some event coming from these external system, and optionally you can have a payload and metadata. In the similar way, so as you can see that once I get any information from, like, as I told you that this is cloud events, and in a similar way, output. I would like to execute, I would like somebody else so that people outside, like services out of my system, can also subscribe to events happening inside me. So Dapr gives you functionality of both input and output binding. The next building block is secret management. So as you can see that here my application code is requesting to its Dapr sidecar that I would like to do something with the secrets. This is the wall I'm using, and you can choose any component. You can use Azure Key Vault or Google Key Management or HashiCorp or anything. So all with a change of a few configuration parameter, I can change the underlying secret store. One of the very strong programming model these days for building microservices is virtual actor. An actor is a stateful object of storage and compute. Dapr provides you full features for helping in building this virtual actor model. So it helps you with distribution and failover of these actors. It helps you with turn-based concurrency. It helps you for state management, and also these provide you a high level of resiliency. As you can see that one host failed, then Dapr changed the placement and moved all the actors to a different host or pod. Now I would like to show you that if you take, because I have shown you all my demos in self-hosted mode, but you can still take these uh, these application and deploy to any containers like Kubernetes. So as you can see that here my application code is running in a Kubernetes pod, and then it's speaking to its sidecar um, over HTTP and gRPC API. And all I do is by just a small amount of annotation. So whenever I do an deployment, I just have to make some annotation where I have to say that this is Dapr enabled, what is the Dapr port, and what is the name of my application or service. Now, one very important thing is that you will see a rise of gRPC API, and that's the reason Dapr also provides um, a way that you can also use the gRPC API. You get this out of the box line by gRPC proto-generated SDKs. But when you look for SDKs available for Dapr, there are some very well crafted clients also. And these very well integrate with this application framework like virtual actors, functions, logic apps, ASP.NET Core, or Spring Boot. And many more are coming. As I told you, Dapr is initiative done very much with help of community, and that's the true beauty of open source lies. And most of these contribution come from community, and we see a lot of traction in coming days. And if you just see that in just last 6 months, the number of components and contribution has increased tremendously. Now I want to show you something as last demo of this presentation. I would like to show you that how I am using the .NET Core SDK for Dapr in my ASP.NET Core applications. So I'll start my. So here I have cloned the .NET SDK repo on my machine, and I'm into the sample folder, but you can get this source code also for this SDK over here. You can see that there are some high level wrappers for actors, for ASP.NET Core, clients, and other things. And one of the demo which I would like to show you as part of this session is um, ASP.NET routing sample. So I'm going to use an ASP.NET Core example, and I'm using an example for routing. This application is a not so secure banking application where I will be depositing money, I will be extracting money, and I will be checking my balance. Let me start this application. I'm opening a new terminal. So what I'm doing is that I'm starting an application, an ASP.NET Core application, and the source code for this application is here. So I'll start explaining this. So this is an ASP.NET Core application, which is the new lean framework for building web applications. And I'm utilizing the Dapr SDK over here. And as you can see from this call, I'm enabling my application for being a Dapr client. And this is where all the magic is happening. And once I have this thing available, I'm mapping my endpoints like the get endpoint and the post endpoint, and then I'm calling this function deposit withdraw. So let me first start this application and show how it works, and then I'll come back to the code. So I have started this web application with Dapr. It has started. Okay, there's some error. Okay, now it has found the application. Application discovered on port 500, 5000. I have an error. Okay, let me check it. So this, by showing you an error, I'm showing you the how hard it is for the developers to build the application. Hope I'm on the right track. Kill this terminal. Just building the application once more. Lynn, any feedback on why I'm not finding the application? Oops. Okay, so this application is not helping me. Maybe I'll run to my different application. Okay, so my another demo, which is again with the Dapr client, the controller application is working. Apologies for not routing application working, but as you can see over here, my controller application, and in this application, I'm making this application Dapr enabled. So what I'm saying is that the moment you add the controllers, you add make it Dapr enabled. And once I have this, I'm enabling the endpoints, and I'm actually I'm adding handlers for pub and sub scenarios, and I'm also adding controllers. And one of the sample controller for this application is over here. I have built applications. As you can see that I have these controllers and these methods. So I have created one for HTTP GET account, and I have a topic for deposit, which is one of the scenario for pub and sub, and then I have for withdraw. So let's play with this application. So what I will do is that I have a sample HTTP file over here, and I will post messages to this application. And at the same time, I would like to keep my console window on so you can see what is happening. So first, what I'm going to do is that I'm going to post a message to deposit an amount. And because I already had some balance in my account from before, now I have added 12 to it. And now the total count is 26. In the same way, I can go back and I can post request and I select withdraw some money. And as I can see, it's 26. I'll withdraw all of it. I need money. I need a faster machine. And balance is 0. Again, I'm going to deposit some money. And now this thing. Now I would like to check my balance. And again, I'm issuing a get command. And I have it 12. Now I would like to show you one more scenario, because this is what I am doing is that I'm directly calling my functions directly the endpoints and checking the value. There is another way also, is that I can go and actually post messages in form of topics. So I'll just come here, start my command prompt, because PowerShell does not respect the codes, and see this. I'm publishing a message and I'm saying withdraw money. And how much? 15. I hope, no, it will give me 0, but let's try it. And then at the same time, I'll see, I hope to see some menu. So this time I'm showing a different functionality, which is called as pub/sub. I have requested, give me my money. And I hope, so see, it has deducted the money. So I withdrawn 15. So now I have credit. So I need to give back. So by this, I have shown you a scenario that I can not only call an application by calling the standard HTTP endpoints, but I can also publish topics. I can, okay, it's because it's too low. I need to deposit some money back. I don't want to keep bank's money. And I'm going to do a next topic. And this time I'm saying deposit. And I'll show you in the code how does it work. I have deposited 15. And I hope it's deposited into my bank. So yes, I have again 12 as deposit. I hope it makes sense. And everything, the topics and everything is mapping in the sample controller. So you will see over here that in this controller, I'm also subscribing it to the topic. So you see, just by decorating this controller function with deposit and this one with withdraw, I'm automatically mapping a request to an action. So yeah, that's all I have to show you for Dapr. As I told you before, Dapr is pretty much a community effort. We would like to join you on our community and help us to take Dapr to the next level and grow it. Yeah, that's all. Thank you very much. And let's start with some Q&A.